Recording in progress.
All right, are y'all seeing it now?
Yes.
Okay, thank you for letting me know that. Okay, so now that we can all see it, okay, so what we're covering is in the chat, and that's not from me, that is from Dr. Pam. So that's like Dr. Pam's approved version right there. Okay, so I'm going to start off with that, and then later we're going to work some questions together, and y'all can ask me questions or each other questions. Let's see here. Okay, so basically, right, we have what's called the correlation coefficient, right? And I've seen this confuse a lot of people. Y'all can let me know how you feel about it, but I promise it's not confusing, right? All that's happening is there is a value of -1, 0, and +1, right? And it's not telling you is something wrong or right, because when we hear negative and positive, right, we're so funny. We always think, oh, something's bad or something's good, right? It doesn't mean anything like that. It just has to do with relationship, right? Correlation is relationship. Have you ever noticed, like, in the word there's relation, like literally in the word there's relation? It's just about relationship. So the closer you get to either the -1 or the +1 in either direction, that's going to be a stronger relationship. The closer you get to 0, that's a weaker relationship. Now, what I usually use is the NCE, because that's the test we have to pass to become licensed as counselors. So I'm just going to stick with that one, but y'all can translate it to social work. So, right, when we go to take like the NCE as a counselor, the more I study, the more I come to groups with Dr. Pam, the more I meet up with maybe an individual tutor, right? The more I'm studying, I think of it like one arrow going up, up, up. And usually, here the correlation, I would imagine there's a relationship with my grade going higher and higher, right? The more I'm studying, see how the arrow, I think like I use my hands a lot because I'm really kinesthetic. So one arrow is going up, up, up. That's me studying, meeting with Dr. Pam at these groups. And then my grade's going up, up, up. Both arrows are pointing up. That is the positive correlation, okay? And by the way, don't let it fool you. Both arrows can also point down. When it says a positive correlation, it just means the arrows are pointing in the same direction, okay? When you have the negative correlation, the arrows will point in different directions. What that would look like, the more I party, okay, and hang out with my family, and I don't study and I don't come to groups, right? That's going up, up, up. Probably there's a relationship with my score is going to go down, down, down. See how they'd be going now like in opposite directions? That's all it means. The 0 means there's no relationship at all. So that would be like I go to take my test and the color of socks I wear that day. They might make me feel more cheerful if I wear like bright green socks with gold polka dots on it, right? But it's not going to actually affect my score. There's probably no relationship there. Here, that would be like a 0. So that's the first thing to think about. All right, how are y'all feeling about that? Does that first part make sense about the correlational coefficient? Maybe Sophia, I'm seeing yes. Um, Anyone else have any thoughts on this? Do y'all feel like that's thus far pretty clear? Maybe? Okay. So, all right. The next thing we want to look at, okay, with this is some common pitfalls that happen, and that is when people see a more negative number. Do you see that -0.70, -0.70? Well, they see that and it's lower than 0.30. I see people do this all the time. They're like, oh, it's much more negative than the other. So it's like a lower value, right? They go back to like our basic math with number lines. No, it does not mean that. Remember, this has to do with relationship. The closer it is to -1 or 1, either direction, the stronger the relationship. So because -0.70, so -0.7 is closer to the -1, that's actually stronger than 0.3, right? Because 0.3 is further away from a +1, right? So whichever number you have that's closer to either -1 or +1, that one's going to be the stronger relationship. Okay, does that make sense? Because that one I know confuses a lot of people. Maybe. It kind of makes sense. Sophia, what do you think?
It kind of makes sense.
Mm-hmm. No worries. We can work there again. So, um, sometimes it helps if people to like draw it out. So you know how I think part of what can be confusing is we're all coming from like when we were little and we had number lines, right? And you know how there's like the zero, and then the number line to the left is like the negative numbers, and we're used to thinking of that as like a lower value. And then we have above the zero, and that's going positive. And we're used to thinking of that as like, oh, we're getting higher and higher, right? Like it's a good thing. But this has nothing to do with that, literally. All it's saying is that I want to figure out, is there a relationship here between these two things? Is there a relationship? -1 or +1, either one is the strongest relationship I could have. The only difference between them is if it's negative, one's going up and one's going down, like this. Like that's why I said the more I party and hang out with my family, the lower my score is going to be because I'm not studying. Here, the relationship, if I'm the closer I get to a +1, all it means is both arrows are going up or both arrows are going down. They're traveling together if it's positive. So the more I'm studying and I'm hanging out with Dr. Pam instead of all my friends and family, right? The more I'm doing that, the more my score is going to go up. They're traveling together. That's all the positive means. The negative, all it means is they're going in opposite directions. The positive means they're going in either both up or either both down. Okay. So did that help maybe a little bit more? So think of it, that's why Dr. Pam has on here. See right here, she has closer to positive or -1. See that one right there? Stronger relationship. That's all it's looking at. Then she says down here, sign like plus or minus. So whether it's positive or negative, that's the direction, not the strength, right? If it's positive, they're both moving up or they're both moving down. If it's negative, it just means they're moving in opposite directions. That's all it means. 0 means no relationship at all, right? The socks I wear on the day I go to take my test most likely will not change my score. Then she just has some of these exam traps like I was telling you. Like here's another one. Like, all right, if I have a -0.8, all right, is -0.8 getting closer to -1? Excuse me, is -0.8 getting closer to -1, or is it getting closer to 0? Does someone know? So it's net, like think about, do what now?
I think it's close to -1.
Absolutely. Thank you for answering that. Yes, it's getting closer. And that's why Dr. Pam has, it's stronger than -0.7, right? So the closer you get to either a -1 or a +1, either one, the stronger. As it moves back towards 0, it's getting weaker. Okay, the last takeaway here, this one's super, super important, is correlation is not causation, right? Just because something's correlated, there's a relationship, doesn't mean it caused it. And that can show up on questions sometimes. That's why she's emphasizing that. All right, so that's the first concept, okay? Now, the next one is sampling methods. So when we take our samples, there are just different methods we can use to take samples. That's all it means, right? Random, obviously, is kind of like by chance, right? Kind of like throwing the dice, right? Or you shake stuff in a little container. You know how you'll shake it and then you'll take somebody's name out. Like it's just random. So there's simple random, stratified random, and cluster. Okay, these are like the 3 main random types of sampling. Then you have methods that are just by convenience, right? It's non-probability. It's just by convenience. It's like what's called kind of like the man on the street interviews. You just literally are like, imagine you're working somewhere. This is right. You know how those sometimes take samples of people in a classroom setting or at a job. That's convenience, right? They're convenient. They're already there. That's all that's talking about. Now, something to point out back up here with the probability sampling. This is going to be better if you want to take your results and apply it to people out in the population, right? This is the one that you would pick. You would pick one that's done randomly or probability sampling. Now I'm going to go back to these one more time. I don't see it here, but I'm going to run through a little bit. These are important right here. So when you have simple random, it's literally like you have a candy bowl full of candy, and you shake up your candy bowl, and you like close your eyes, and you pick out a piece of candy. That is simple random, literally. Every piece of candy has an equal chance of being chosen in that candy bowl. It also has an equal chance of not being chosen, right? So you will close your eyes and you'll pick out a pink piece of candy that's peppermint. Well, that was totally by chance, right? You didn't pick up the glitter candy, right? That tastes like what's something we all like, or something we don't like, licorice. I don't like licorice, right? So that's simple random, okay? Everybody has an equal chance of being chosen or not chosen. Stratified random, all this means with stratified is first you're going to divide your people up into strata. I think of it kind of like layers to a cake. So you have like your banana layer, you have your mango layer, you have your chocolate layer, right? You have like all these different flavors of layers to the cake. And then that's your strata. Here it's in like groups. Then you're going to randomly pick the people for your study. Do you hear it? But first you put them into groups, right? Or imagine you have corgi dogs, okay? And you have all your tan corgi dogs, and you have all your cream corgi dogs, right? Here at first you're going to put them into strata, and then you're going to randomly pick, okay? So that's the difference between these two types of random. With simple random, you don't put them into strata first. You just like shake up the candy bowl, pull out a piece of candy. Stratified random, first you put them into groups, right? You put it into strata. Then you randomly pick out someone, okay? A cluster is kind of a little weird at first. It's imagine, since I was talking about corgis, we'll stay with dogs, right? Let's imagine you are going to pick a kennel, and now you're going to study all the dogs in that kennel. You pick a kennel, all the dogs in that kennel. I see it a lot in problems and like practice questions for the test with like schools, right? You'll pick out like a school, and now you're going to sample everyone in that school, or a neighborhood, right? You pick out that neighborhood, and now you're going to do everybody in that neighborhood. Do you hear it? Or like out of the people of that neighborhood, right? That's cluster when it's based on like that one place, right? Like you pick a place, now you can randomly pick people from that place. So those are the three main probability sampling methods. Did that make sense right there? The simple random, the stratified, and then the cluster. What do y'all make of that? Kind of. Yeah, kind of good. Any questions on that?
Can you explain cluster again?
Absolutely. Yeah, that's the one that I feel like can be a little weird at first. So basically, all right, you know how like in strata, I said you first put people in groups like strata, and then you randomly pick them out? Well, with cluster, what you do instead is you'll pick like a location, like a neighborhood or a school. I see a school or neighborhood a lot. Like I was using dogs to kind of be silly and just make an example, like a kennel. Then once you pick like that one place, then you're going to randomly sample the people in like that location. But it's called clustering when they do it that way. Good question. All right. And then these are just, like I said, these are just convenient sampling, right? The volunteer, the accidental, the quota, you have to have a certain number, the men on the street interviews. Okay. One of the important things to remember about those, y'all, is when it's convenient sampling, this cannot be generalized to the population. Those are not good. The data you gather from that as a researcher, that data, you can't generalize it to the population because you didn't randomly pick people from the population. So that's important to remember for that. Okay, let's see here. Then, as a researcher, we just have these designs we do. That's all this means. I'm going to research people, and I have to have a design to be a researcher. If it's cross-sectional, all that means is like snapshot in time. 1 point only. I wonder, I have a PowerPoint that I use for NCE, let me see, that I like this picture in here. Let me see if I can find that for y'all. Over here. Okay, let's see if Zoom will let me share this. Okay, right here. This is the difference between cross-sectional and longitudinal. They do this all the time, which is why I have a picture just for that one specifically. A snapshot is, like I said, it's literally just that one snapshot in time. You'll have different people. It's like us literally right here sitting in this group. If someone wanted to research us and they did like this one snapshot in time right here with us. Here we have different ages here. We have different heritages here. You see what I'm saying? Like here in this picture in cross-sectional, they're using different ages. But it's like different people at this one place in time right here, right? You get like different ages and different heritages and different lots of things, right? If it's longitudinal, do you see how the word long is in there? LONG is in longitudinal. It literally means that over a long period of time, you're going to track the same people over a long period of time. That's all it means. All right, so with cross-sectional, different people, that one snapshot in time, you're done. So you just have like that one snapshot of us like today. No more research on us, right? Versus imagine Dr. Pam's researching us, right? That would be, I think, kind of funny. And let's imagine if she followed all 4 of us here for like the next 20 years to see, oh, you know, I wonder what these people did after they left working, like, you know, working here with Dr. Pam, right? Like, where did they go and what did they do? That would be longitudinal. So that one, I know they use quite a bit. Okay, now coming back to this one. All right, so that took care of the next 2, y'all. My screen got all wonky. Wait, okay. What I should, okay, here we go. All right, so we did cross-sectional, we did longitudinal. Oh, experimental. So experimental basically means you manipulate an IV. That's why it's called an experiment, right? So you as the researcher, you have an IV, which is the independent variable that you're going to manipulate or control. All this means is, y'all, I was telling them last night for the NCE, like, do not overthink this stuff, right? Like, it's just cause and effect. Like, we do it, Dr. Pam says this, we do this stuff all the time. We just don't call it these words, right? But we do this literally every time we put on makeup. It's literally like an experiment. We're controlling the IV and we want an effect. Usually our faces, right? Every time we add something to coffee or tea, I don't know if we have any coffee or tea drinkers here. Do we have any coffee or tea drinkers here? Yes, right? Literally, every time you put in honey into your tea or cream into your coffee or whatever is your thing, that's literally your IV. You're manipulating it, right? You're like, oh, I don't think my tea is sweet enough. And so you put more honey. That's the cause, is the honey. And the effect is you want it to be sweeter. That's all an experiment is, okay? And when you're on the exam or whatever you're studying for, that's what it means by an experiment, is you have an IV and you manipulate it. Descriptive, I think that one's easier too, because it literally is like the word. I mean, think about it. This is called descriptive research, and that's all it does. It just describes something. The difference being, you know how I was just talking about tea and coffee, and let's say I want to keep adding honey to my tea. Well, when I'm doing a descriptive research, I don't manipulate. You see how it says no manipulation? Instead, I'm going to be like, oh, Sophia, let me describe my tea to you. It's pink with petals in it, and I see steam coming out of it here, but I'm not changing anything about my tea, right? I'm literally just describing it. That's descriptive research. You just describe it. You don't change anything. You don't manipulate anything. Then, of course, you have the case study, right? And this is usually really in-depth, right? Smaller samples. And this part's important to remember. You can't generalize the data from a case study. right? Because I could study mastermind masterpiece for 20 years and have the most amazing case study, right? But it doesn't mean I can apply that data to Jennifer or to Dr. Pam or myself, right? So case studies are great, but you can't generalize your results to other populations and other people like that. Okay, Dr. Pam says, know this code. Do you see her right here? She says, know this code, the variables. It's because they like to ask questions on this quite a bit. So the independent variable, like we were literally just talking about with coffee and tea and honey, that's the cause. That's what you're manipulating as the researcher. In therapy, if you're doing therapy with anyone, that would be your therapy right there. We're going to use therapy as the thing we manipulate, right? The dependent variable would be the effect, right? So let's imagine we have someone with a lot of anxiety, super high anxiety, right? And let's imagine we're going to try CBT, right? It's very evidence based. Or we could do EMDR, of course, if they have trauma, right? But that's our independent variable. What we now are going to watch is the effect, right? Okay, does their Beck depression inventory, well, I was talking about anxiety, does their Beck anxiety inventory come down? Does that score come down, right? That's the effect. That's all it's talking about. Okay, and then Dr. Pam has here, and this is interesting right here, intervening variable between the IV and DV. And I'm wondering, is that maybe more of something in social work? Do y'all know about intervening variables? Is that new for y'all? This antecedent and the intervening variable is new for you? Okay, that is interesting. And then anytime we see antecedent, that just means it goes before. So that's what goes before the IV. Okay, we all know a placebo effect, right? This is like they give you that sugar pill and you call all your girlfriends and you're like, I feel so much better, okay? But we weren't given anything. It was literally a placebo effect, okay? Sadly, it sometimes really does cause that. Okay, levels of measurement. This is from the weakest to the strongest, okay? The weakest is nominal. It's just a category only. It's like gender. That's literally, it's just categories. There are no numbers here. That would be nominal. Ordinal is just like first, second, third. What's your class order? I'm second. What did you get at the Olympics, right? First place. Here, it's just ordinal. It's just first, second, third. Interval, you want to memorize this part. An interval has no true zero. And it's things like a thermometer. I know this is weird. This feels weird at first, but like with Fahrenheit, there's never truly no temperature. I know that feels weird at first. I don't know if I've even ever thought of that much before in life, but there's not ever truly, to use some bad grammar here, there's not ever truly no temperature, okay? But what you do have on a thermometer, right, is equal intervals, right? Like you have 10 degrees and you have 15 degrees and you have 20 degrees. Do you hear how there are equal intervals? I know that one's weird because like we can say 0 degrees outside or -5, but there's never truly no temperature. That took me a little bit of thinking at first. With a ratio, you do have a true zero. So that's things like weight and income. In other words, you can double it. 100 pounds is double 50 pounds. 20,000 is double 10,000. Here, if something has a true zero, it can be doubled. That would be one of the clues in the questions, right? If you see something that's like being doubled, that's a ratio. It can have a true zero. See, oh, that's what Dr. Pim used right there. Twice as many clients. That's a ratio. If it's not a ratio, then you can't do that, okay? The way I remembered this, I don't know if y'all are having to remember a lot for a test or not, but the way I remembered it was Noir is noir in French, which is black, noir. And so that's how I remembered it. It literally spells noir in French, no joke. Like you don't even have to do anything to change it. So that's how I remembered it. That helped me remember that for my test. Okay. And, all right, any questions on what we've covered thus far? What do y'all think? No questions? Is it that easy?
No. Will this video be available? Again?
Will this video be available? Absolutely. To my knowledge, they will post it probably tomorrow or Tuesday.
Okay,
Yes, ma'am. Yes, ma'am. All right. Let's see here. All right. So now we're on to central tendency. Okay. So is there? Yes. Okay. Do y'all know the bell curve? That normal bell curve? Have y'all heard of this? Seen it? Thank you, Jennifer. Yeah. So Dr. Pam talks about it a lot. The 68, 95, 99 rule, right? Dr. Pam talks about that one a lot. But it's the normal bell curve. And in other words, most people have an average weight, average height, average IQ. Most people are average, right? We're at the middle of that bell curve. I sometimes use like something like playing piano, right? If somebody plays piano, most likely they're average. They're like in the middle of the bell curve. Then you can be above average or below average. That's like 95%. If you're like a genius on the piano and you know like one of those prodigies, you're like the 90 and that 99 above, or like 99, you can be way below. That's all that's talking about. So when you have that normal bell curve, there's like a central tendency towards that middle, right? And I think of them like M&Ms. It makes me think of M&Ms, the three M's, M and M and M. It's like M&M candy. The average is what this is really important here for the test, is affected by outliers. So if you have like, let's say us here, let's say we're all, I don't know what we are, but let's say we're all about 5'5" in height, around 5'5" or 5'4" or 5'6", somewhere in there, right? An outlier would be like someone coming in who's like 6'3" or 6'5", right? Or somebody who's like 4'5". Here, they're like either way above or way below what our average is here in height. And when that happens, it affects the average. When you have outliers, it like skews that average. It's called skewing. It'll make it either skew to the right or it will skew to the left. But you won't have that bell-shaped curve anymore. The median is just the middle score. I think of it like, and I've heard Dr. Pam say it too, like the median in the road, right? When we're driving, there's a median in the middle. It's the same here. It's just the score that's in the middle. The mode is the most frequent, but it tells us the least information about the people, the population. So let's say, again, out of us four here, let's say we take a test and the average is, let's say, an 80. But let's imagine two of us here scored an 83. Just imagine there's an 83 that was made twice. Okay, that's the mode. Here, it's just the most frequent score. That's all it is. Then you have what's called variability, because things vary, right? And the most important one to know for most of these tests is the standard deviation. And I kind of think about it like kind of like spreading cream cheese or peanut butter on a bagel, right? Like in the middle of the bagel, I know that sounds kind of weird, but in the middle of the bagel is kind of like the average, right? But then we have like around that, like our spread of scores, right? That's just the standard deviation. So this one's kind of, think about it. This one's kind of obvious. If you think about it a second, the smaller your standard deviation, in other words, the smaller that spread of scores, right? The more homogeneous, which just means like the more all the same the group, right? So let's see, do we want to use a test score or height again? We'll use height again, right? So let's imagine we're all about 5'4", and let's imagine, remember the spread around it. So let's say some people are 5'5", some are 5'3" here, but it's still really close. So we don't have a huge spread. But now if we get like 5'7" and 5'2" and 5'9", and here we're getting more and more spread all over this place, that's going to have a greater standard deviation. But the smaller the spread, the more homogeneous. We're like more alike in some way. We're more alike, whatever they're looking at. Okay, now here's that normal bell curve, guys, that Dr. Prim's always talking about. And she just says memorize it. See right here, she's even left us a note, memorize. So again, I'm just if you just think about it y'all, like everyday stuff. Like, okay, 68% is where most of us are. That's the average height, average weight, average IQ, average everything. And we fall within one standard deviation, right? A little bit above or a little bit below. But that's that part in the middle. We need a picture for this. Let me see if I share something different. Let me go to this is so I had this really cool bell curve. Where is it at? And then you know what happened? So here's the one I drew by hand, kind of messy. And then I put it into AI. I was so excited, and I asked it to make a K-pop version, and it was so beautiful. You should have seen it. We are like, oh, it was like all glittery and K-poppy. And guess what? We started looking at it. I knew what ChatGPT had done. It had repeated the +1 twice and had messed up this area right here. So I have to try again, and it never would get it right. I did it over and over with ChatGPT. I was like, please remove the extra ones. And every time it keeps putting extra ones in. So y'all are stuck, and they were stuck last night with this messy one by hand. I was like, I have to take it out, y'all. Like, it's really pretty, but right now you just gotta have it right for the exam, not pretty, right? So this is all that bell curve is right here. Do you see the middle part that's like purple? That's the 68%. See, it's like +1, -1. That's in the very middle. I think of it kind of like a rainbow. That's where most of us are. Then from the -2 to the +2, like a standard deviation of 2, that's what Dr. Pam's calling that 95%. That's less of us. You're going to be either a little above average or you're going to be a little below average. The outliers, like you're either way above or way below, that's the 99%. That's that really small group of people. See this big blue one? That's that last one, 99%. And that's the plus or minus a standard deviation of 3. That's all it's talking about. And then what I have under here, the 0, 1, 2, 3, and then the 0, -1, -2, -3, that's our standard deviation. And then on the NCE exam, y'all have to tell me. I don't know about on the exam y'all have to take, but like 3 of the most important ones we have to know is like the Z-score, the T-score, and the IQ. Right, so like the cool thing about the Z-score is exactly the same as the standard deviation. It's still just 0, 1, 2, 3, and then -1, -2, -3. That doesn't change. The T-score is that one, like I had to memorize. I just remember T is for 10, meaning it moves by tens. So at the average, right, here's the average right in the middle. For a T-score, it's 50. And it goes 60, 70, 80, right? It's moving by tens. That's what I mean by the T is for 10. The IQ, see right in the middle, I have everything aligned. The IQ, the average IQ is 100, and it moves in standard deviations of 15. So it goes 115, 130, 145, right? And then to the left, you just then subtract. You subtract down to 85, and then you just subtract on to 70. The other reason I have it drawn out like this is and some of the questions we get, that's why it's like, y'all may have to help me out here. I'm not sure if it's the same. I should have asked my sister, but sometimes we have to work with like the percentages for some of the questions. So half of 68 is 34 and 34. Meaning, right, so like you have that middle, and in the middle, the average, and that means like if you're going from 0 to +1, you wouldn't include all of the 68%. Excuse me, it would just include half of it, right? Because you're just on the positive side. So you would need to know, oh, that's 34%, right? And then half in the next little arc in the rainbow, if you're on just the positive side for the 95%, it's only 13%. And remember, 99% is like the fewest number of people. So that's literally the half on the positive side is only 2% of people, literally. On the negative side, like below the average, that's only 2% of people. So that's why those percentages are there like that. But that's just that normal bell curve. That's what all this is talking about right here. Okay. Now, when we have our assessments that we use with our clients, right? So You know, we have like the Beck depression inventory and the Beck anxiety inventory, and we have a ton of them, right? We have a lot of these like different assessments with our clients, right? Thankfully, researchers already did all this for us. But when they were checking them out, two of the main things they were looking for was, is this assessment reliable? And is this assessment valid? And if an assessment is not reliable and valid, like, we can't use it. It would actually basically be like, it's like unethical to use it with someone if an assessment is not reliable and valid. So another way to think about reliability is just consistency. I cooked chocolates today with a recipe. It turns out the way I want it to. In another week, I think, I'm going to try this recipe again. Guess what? I get the same great chocolates, right? I'm like, wow, this is a great recipe. Every time I'm getting these great chocolates. That's consistency. It's a reliable recipe. And that's why I keep using the same recipe, because I get great results every time. Validity is something totally different. That's accuracy. That's like, okay, I'm expecting this to be chocolate, right? Is it truly chocolate, or is this like peanut butter, right? Is it accurate? Another way of thinking of this, I love, that really helped me, Dr. Pam's dating example on a dating app, right? And she's like, it's like meeting a guy, and she said, it's like he calls you every day, he shows up every time he says he's going to show up, right? He's like super reliable here. But he said in his profile, he's like a prince with a lot of money, right? Well, obviously, you look into him, and of course he's not a prince, right? With some kingdom. Of course not. So he has reliability, but he doesn't have validity. He's not who he says he is. Okay, so that's like the big picture for this. Here's where life gets really annoying, okay? Is they have different types of reliability and some different types of validity, and they're kind of a pain. Okay, so for reliability, I think the easiest one is the test retest. You literally give a test. Like, let's imagine I gave y'all a test today. That would be awful, right? Let's imagine I give you a test. I come back, Dr. Pam has me come back in 2 weeks and give you the same test again. And then Dr. Pam and I compare the results. That's all a test retest is, literally. You give a test, then you wait usually about 2 weeks, and then you give the same test again. When you're reading the question, kind of the giveaway will be same test, same people. Here, same test, same people, usually about 2 weeks apart. That's a test retest. So I think that's the easiest one to remember. Another really easy one is the parallel forms. I've also seen this called equivalent or alternate. So just be aware of that. I've seen this also called equivalent or alternate. These are two other words I've seen them use quite a bit. And all it means is, Sophia, you said you did take one of your exams already and passed it, correct?
Yeah, but that was a couple of years ago.
Yes, well, can you help me out then with this question? So, like, for the NCE, we have like the same exam but different versions of that same exam. Is that how yours works as well?
So yeah, we have about, I believe we have a couple of versions as well.
Okay, perfect.
So ours, they don't really go deep in like Z scores and T scores, but what they do test you on is the reliability and validity and the different kinds.
Ah, thank you for telling me that, Sophia. Beautiful. That's why I was like, wait, let me tap someone in here. Okay, so then that's perfect, because that's what I used to explain this, like for the NCE people, like last night, is, you have like that one exam, but they're just different versions, but it's that same exam. That's what's called parallel forms or equivalent or alternate, right? That's all that means. Thank you, Sophia. That was a big help. And then for the split half, again, it's just how it sounds. You take the test and you split it in half. A lot of times what they'll do is they'll split it based on like even number question and odd number questions, for example, right? They'll take the test and they'll split it in half, meaning they'll take all the even number questions and check all those out to see if they're reliable. And then they'll take all the odd number questions and they'll check all those out and see, is it reliable? Now, what is weird about this, okay, is, and I have seen questions about this, is when you split something in half, when you shorten an assessment, it decreases its reliability. And I think that's so funny. Because, right, I'm like, wait, think about the logic of that. You're trying to see how reliable something is, but you split it in half, which shortens it. And when you shorten something, it decreases its reliability. So I always think that's kind of funny. So that's the split half. I'm not seeing... Yeah, we're gonna just stick with the split half. Good. And then you have inter-rater, okay? All right, can someone tell me, does someone know what the inter-rater is, maybe? I mean, I know, but I didn't know if one of you might know as well. No? Okay, so inter-rater is just where different raters, I think of it like different raters, different scorers, people who score, rate or score the same assessment or person. For example, at the Olympics, right? The figure skater twirls over the ice, right? She finishes. Well, Germany has a score, the US has a score, Russia has a score, right? All these different countries will score that person. That's inter-rater. Or, like with Dancing with the Stars, right? You know how people can like rate the performers? That's literally inter-rater. That's all it is. You have different raters, and those different raters rate or score this same assessment or this same person. Okay, which also makes sense. I mean, this helped me too, because one example I heard one time was like when you write an essay, that can be pretty subjective, right? Some professors might give you like 100 on it, and then another professor on the same paper might give you like a 90 for real, right? Like, and that's what inter-rating is supposed to help with. It's supposed to help make it more fair to the person, right? Because some things in life are really subjective, like essays. Okay, validity, like I was saying earlier, that's accuracy. Is this assessment truly measuring what it's supposed to be measuring? So, for example, on the Beck Depression Inventory, okay, it says depression, but is it truly measuring for depression? That's all validity is. Okay, it measures what it claims to measure. What this means right here, the content, the criterion, and the construct. So with the content, I'm going to go back to, in a second, y'all. I'm going to go back to the one I used for for the NCE pupil last night. So right here, so there's face validity, and that's the easiest one. That's where something is what it looks like it is. It's literally like you see a math book and it says math on the front. You don't even really go any deeper. You don't even open the book to see is it truly about math. You just see the cover. It literally means face. You're going by the face of something. It is what it looks like, right? So content, I think of it as like domain. So for example, when we go to take the NCE, there are like 8 sections we expect to be tested on. And we've been studying for those 8 sections. Do y'all know how many sections you have to study for on your exam? Like there are like 8 domains. I'm sorry, I should use the word domain. There are like 8 domains we're going to be tested on. Do y'all know how many domains y'all have?
4.
4? Oh, that's so cool. Okay, what are they? May I ask what they're called?
You got human growth. You have assessment, diagnosis. You have ethics. And there's another one. I may have combined 2. It's 4. They're going to 3, but it's 4.
Okay. All right. Thank you. That was actually really helpful. So that way I can say it for y'all instead of like for the NCE. So it's like when you go to take that test, you have those 3 or 4 domains, and you've been studying for them, and that's a content validity. You expect to be tested on that content, on all those domains, right? We don't expect to be tested on calculus, okay? That would be terrifying, actually. Predictive is what it just sounds like as well. It literally just is going to predict something. That's all that's going on with that. I think the 2 that are For me, at least, the two that were the hardest to get down were concurrent and construct. Concurrent just means at the same time. Like that word in general is just like simultaneously. So when you have concurrent, you have, like, let's imagine Jennifer wants to come up with a new anxiety measure for children, okay? Or I'm going to stick with something we all know, anxiety, just period, okay? Because then I can use Bex. Well, she's going to come, so she comes up with her new anxiety assessment, right? But the researchers have to come in and see, okay, does this have concurrent validity? And they're going to give her assessment to a group of people along with a gold standard, such as Beck's anxiety inventory, right? Beck's anxiety inventory is like a gold standard, right? And what they do then is they see, does Jennifer's correlate, do her scores that people are getting, do those scores correlate with Beck's anxiety inventory? That's all that means. Concurrent. So if you're in a question and it has like, if it has like a new assessment, and then it's like they give it at the same time with like a gold standard, that's going to be concurrent. Like those will be like how it will be worded. Construct. All that means is in society, we have like constructs we've made. And this kind of cracks me up, right? Like, because when we go to the doctor, they take like our vitals, right? Like our blood pressure and our oxygen levels and our what else? Our temperature, right? And it's very simple, right? They like hook us up to something or poke something in us, right? And then they get a number, like your blood pressure is like 110/80 or whatever, right? And they're done. But when we go, they can't like just poke us or stick us with something or take a number for our levels of happiness or our levels of like quality of life or our levels of sadness, right? So that's a construct here. When you can't mathematically, you can't just hook someone up to like a machine or something and figure it out. It's just something society's constructed. You know, what does happiness look like, right? What does sadness look like? That's all construct means. Assessments that measure for happiness, assessments that measure for depression. All of these are constructs. That's the easy part. Here's where it gets weird, okay? Construct validity can be broken down into two types. There are two types of construct. One is convergent, right up here, convergent. Okay, and one is divergent or discriminant. When you have convergent, this is why I said at first I used to get it confused with concurrent. So don't get it confused because I used to. When you have concurrent, it means you have a depression inventory and it's going to strongly correlate with another depression scale. They converge. They like come together. This is why Dr. Pam uses that poem all the time about the two roads in the woods, and she took the road less traveled. That's why she uses that here. If it's convergent, both of your inventories or assessments, they're going to correlate. Okay, in other words, let's put that in plain English. They're going to both be measuring depression. Okay, they're going to both be measuring anxiety. They're going to both be measuring happiness, whatever the construct is, right? If it's divergent, diverge is like moving apart. That's why she says when it says diverge, she says, I took the road less traveled. It diverges off. And this is, you know, discrimination is horrible. That's why one way I remembered this is they call it discriminant sometimes, and it discriminates against what you're not testing for. So for example, if you're testing for depression, you actually, this is one of the only times you want discrimination to happen. You want it to discriminate against IQ, right? You want your test, if you want it to be for depression, you don't want it to be measuring someone's IQ. You just want it measuring their depression. If you're measuring their IQ, you don't want it measuring their depression. Here, they diverge. They're not going to measure the same thing. Oh, okay. So those are the two that I think can be a little tricky, concurrent and construct. And then the last one in this purple box, that's why I have watch out, because for a long time I kept getting these questions wrong. And I was like, what is wrong with me? And then I figured out what was wrong. Criterion validity can refer to either predictive or concurrent. I've seen it refer to both. It can refer to predictive or concurrent. Now coming back to this handout here, let's see here. That's that last one, okay, right there, see, in the middle. criterion. We've done content. That's okay. You know, did it cover every domain that I expected it to cover, right? We did construct. That's something society has constructed, literally. And then criterion. Criterion can just be content or predictive. That's all it is. And then the last thing Dr. Pam has here is reliability is not validity. They're not the same. And this one's really important. I've definitely seen questions on this one. A test can be reliable but not valid. And that's one of the reasons why Dr. Pam's story, the dating story, helped me, right? Because we know people who are reliable but they're not valid, right? They are reliable but they're not valid. They're not they're not a prince, but they are reliable. They will call us every week. Sadly, we know some people like that. Probably all of us do, right? Okay. Let's see here. Well, all right. Any questions before we move on to the statistical significance part? No questions? Okay. Hang in there. You are doing great. We're making progress. Okay. All you basically need to know for this, literally, that's why I kept telling them last night, do not overthink this, okay? Is if you're on your exam and you see that little p right here, that p-value probability, and it's less than 0.05, all that means is it's unlikely that whatever it's talking about happened due to chance, right? If your probability is less than 0.01, see how that number's getting smaller? 0.01 is smaller than 0.05. Then it's very unlikely it's due to chance. So, and these are two of the main ones you'll see. So if it's 0.05, it's unlikely. It's unlikely that this happened because of chance. If it's like 0.01, it's very unlikely. What's the likelihood that very unlikely due to chance? Let's imagine someone takes their test and they made like a super high score. Well, very unlikely due to chance. They probably were really studying, right? A P lesson, but like very unlikely it was due to chance. The observed difference probably did not occur by chance. Okay. All right, y'all, hang in there. We have our hypotheses and our errors. Okay. So when we're doing research, this is all about research. Basically, I'll use CBT again because we basically all know CBT, and it's one of the most evidence-based methods of treatment, right? But let's imagine you wanted to use CBT with a certain population, okay? And when you go into this research study to try your CBT, you would have a null hypothesis. And your null, I just think of null as like not. Null is not. I think of it like not working, didn't work, not worked. Use bad grammar, else remember, not worked, it just not worked, okay? Null hypothesis means that it did no difference, right? You go in and you're like, oh, I want to try CBT with these corgi dogs, and your null hypothesis is it made no difference. It did not help the corgi dogs, okay? So when you finish that research, you have to be able to reject the null hypothesis to actually show that your research worked. You have to be able to reject it. All right, does that make sense? That throws people for a loop sometimes. It does make sense. My goodness, y'all are this is a smart group. This is a smart group of people right here. Normally that throws people for a loop right there. So now you finished your research, right? When you started your research, you had your null hypothesis. And then when you finish, you have to be able to reject it to support, like, my research actually worked, okay? When you get done, there are two types of errors that are common that you have to watch out for when you're a researcher. You have your type 1. And when you hear type 1, just think instantly a false positive. That's the easiest way to keep this straightened out. A type 1, all it means is a false positive. A false positive just means I thought it worked when it didn't, right? That's all that literally means. You also sometimes see alpha. This is an alpha, and type 2 is a beta. But the way I think of it is type 1 false positive, type 2 false negative. When you have a false positive, you think it worked when it didn't. Here it's a false positive. The positive means, oh, this worked, but it actually didn't work. It's false. False negative is you're like, I can't believe it. Like, my research didn't work. And sadly, it actually did. but you have a false negative. You think it didn't work, and it actually worked. Okay, to put this in more researchy type language, and that's part of what makes it feel hard, is a false positive is you reject the true null. Remember, null just means it's not working. So you rejected a true null. In other words, you rejected the null hypothesis saying this didn't work. And you're like, yes, it worked, but it actually didn't work, okay? Type 2 is you failed to reject. You failed to reject the false null. Does that make sense? I know that one's a little weird right here. That's why I said when you see type 1, the thing that keeps me straightened out with type 1 and type 2 is type 1's false positive. As long as I remember that, and type 2 is false negative, then from there I'm able to work out the rest. I wrote that down on my exam. You know how, do they give y'all like a sheet of paper y'all can write on during the exam? Beautiful. When I went in, that's what I did. This is one of the things I actually drew down, was this right here. Type 1 and type 2. Okay. All right. Are we almost done here, guys? Hang in there. Then we're going to do some questions, okay? If anyone's here, we're going to do some questions. No, theory, operation, I'm going to let y'all read that on your own. I feel like that one makes sense. All right, qualitative and quantitative. The only way, like the way I think of this, quantitative, do you see how it's kind of like quantity, right? It's kind of like quantity, right? It's quantitative. It's about a quantity. Qualitative is like quality. I think about it like a quality, right? In other words, it's not numbers, okay? Then you have ethics and your review boards. So an IRB, right, is just there to protect humans, basically, make sure ethics are being observed. I hope we all know this one, right? An informed consent. I think we all know that one, right? You've let people know the risk involved in the research, the benefits, the type, like what's going on with the study, and like they always have a right to leave, right? You can't force them to stay in your research. Oh, that's hilarious. That's so funny what Dr. Pam has here. Monitoring researchers' personal life. That's funny, actually. Okay. It's not. That's really funny. All right, then we have grounded theory and focus groups. I think that's pretty straightforward. I'm not going to really spend time on that one. And then, okay, a cause and causation. Remember earlier we were talking about a correlation does not mean causation, right? Just because there's a correlation doesn't mean it caused it. But this right here is dealing with cause and causation. This is important. Only experimental designs establish a cause. That's important to know. Okay. And then, let's see here. Dr. Pam says final exam wisdom. That is stuff we basically already done, right? Remember, change over time was longitudinal. Remember I said just remember the word long is in there, like over the long haul, right? We already did this right here. Consistency is reliability, accuracy is validity. We already did all this. I don't know if this will help you any, but do you see how the second letter in validity is A, and the first letter for accuracy is an A? We have validity and accuracy. That's one of the ways that I remember that, is the second letter in validity is an A. And I just tell myself that A stands for accuracy. That's how I remember that. Then Dr. Pam just has like a research math survival sheet, but then Sophia was telling me that y'all don't really do that much, like the Z-score and the T-score and all that. So I'm not going to spend a long time on that then. I mean, this, I feel like y'all could probably kind of make an educated guess because, right, if scores are clustered, if you have a small standard deviation, group is homogeneous, right? Anytime you have homo, that's the same, right? Anytime you have hetero, that's different. So you could kind of make an educated guess on that, right? The scores are spread out. Exam traps, okay, y'all can read that later. All right. We already covered this a while ago as well. The first and second and third standard deviation, you know, the first is 68%, the second is 95%, the third is 99%. We already covered that. This right here is really weird. I don't know why they do this a lot, but I've seen them do this a lot. instead of saying 68%, they'll say 2/3 of the time. So if they do that, just know it's the same as the 1 standard deviation or 68%, okay? Almost all scores here, that's like all 3 standard deviations. And then a 95% confidence, that's your, in other words, Dr. Pam's showing us they can word it different ways. You know, she's saying don't be thrown off if they don't say 68%, right? If they say 2/3 of the time, that's the same as 68%, okay? Standard error of measurement. Let's see, we've almost made it, y'all. The amount of time, oh yeah. So when you have the standard error of measurement, it's just how much will your test score vary? If you keep taking the same test over and over, how much is your test score going to vary due to measurement error? So, right, so let's say Jennifer takes her test, right? And then she takes it again. And let's say she takes it again. Poor Jennifer, right? She keeps taking the same test over and over. So their score would probably fall within a certain range. And the standard error of measurement is just showing you how much will it vary due to the measurement error. Like the literal error inside like the test. Not Jennifer's error. And it's just showing you, like, when they do standard error of measurement, guess what? It uses the same 68, 95, 99. It uses that same bell curve. So that's really useful, okay? The standard error of measurement does not equal the standard deviation. People do get that confused. Standard error of measurement applies to individuals, right? It would just apply to Sophia, and it would just apply to Jennifer, and just to me. Versus standard deviation would be like to the whole group. Like all of us when we all take the test, right? And then I'm not going to mention Z-score that much since Sophia said it's not really that big a deal. These are just the percentiles. Let me know if y'all feel like I need to go over that. You know, feel free to let me know. Okay, yeah. So do you see right here it says a trap? Z-scores describe relative standing. So remember, on a bell curve, we're being compared basically to each other, right? There's like an average, and we're like being compared in this average. So what's our relative standing in this average, right? Where students panic. Dr. Pim's so funny. Where students panic and shouldn't, okay? So P, she says, it's a probability. Yeah, that's what we were just saying a while ago. Remember, P is probability. What's the probability this happened? Remember, if it was P, so this must be very important because Dr. Pam has it again. See right here, she says P less than 0.05, probably not due. P less than 0.01, very unlikely. So that must be very important. So I guess y'all really better memorize that. Dr. Pam had it on here twice, okay? All right. Oh, we're almost done. Hang in there, y'all. Yeah, this is the last part. Then we can work some questions. So this says how they combine on the exam. Okay. Oh, yeah, for sure. Right. So standard error of measurement. Think a score range. Remember, it's just that one person score. Like, what's the range of just Sophia's score? The standard deviation, remember, it's like the group spread. It's like the spread of the whole group. Right, there's like an average. Where do all of our scores spread out around that average? The Z-score, think percentile. P-value was just probability. Did it have, what was the probability this happened by chance? Oh, and she does this again too. So y'all must need to really memorize this for y'all's test. The type 1 error, false positive. And a type 2, a false negative. Okay. She says memory trick. Innocent convicted. Type 2, guilty set free. It's kind of scary. Okay, right? So, you know what? I've heard her use 2 before with the type 1 and type 2. Have y'all heard this one? Is she'll use like the pregnancy test. So she's used a pregnancy test 2 before, where type 1 is like you get like a pregnancy test and it says that you're pregnant, but you're actually not. It's a false positive. A type 2 would be a pregnancy test tells you you're not pregnant. And, you know, in about 8 or 9 months, you have nothing ready for the baby. And all of a sudden you're like, I'm having a baby, right? It told you you weren't pregnant, but you actually were pregnant. That's like the type 1 and type 2. Type 2, you think you're pregnant, but you're not. The test tells you you're pregnant. Type 2, the test tells you you're not. It's a false negative. You're not pregnant, but you actually are pregnant. So that's how that would work in like kind of everyday thinking. Oh my goodness, y'all, okay, we made it through research. Usually this is people's like least favorite. What do y'all think? And for the NCE, this is usually people's like one of their least favorites. How is it for y'all?
Same thing. Least favorite.
The same thing. What about you, Sophia?
Same thing.
Well, we made it, okay? We made it. Thank y'all, because I really feel with y'all. Yeah, it's not a very fun section. Okay, you know what? Let's take a small body break. I'm going to plug in my laptop. Here, I'll show you the next thing coming up. Dr. Pam had these questions. She said these were the questions to work on right here. But I'm going to plug in my laptop. We'll stretch around just a second, and we'll come back and work on these questions she gave us. Does that sound good? Awesome. All right. Be back in just a second. Okay. Let's see here, y'all. These are some scary questions. Okay. These are some scary questions, I have to say. If your brains weren't tired before, they're going to be now. Okay. This is going to finish us off. Okay.
Can you explain concurrent again?
Absolutely. I know that one, like, I struggle with that one for a while.
There was that one, and then there was something else you were explaining along with that. I'm still a little confused.
You are totally fine. Probably, let me go back to that slide. I bet probably it was construct. Does that sound right? Probably concurrent.
Yeah.
Yes, me too. I struggled a long time with those.
And that comes in my test.
Oh my goodness. Okay, yeah, let's definitely check it out. So with the concurrent, one of the ways I finally got this kind of straightened out for myself is that word concurrent in English, just period, in general, right? Means like simultaneously. Like I could say, I mean, we don't really talk this way. It would sound kind of funny, right? But I could say Sophia and I concurrently went to the gym, okay? Like you would be like, no one talks like that, Sarah, right? But that's what it literally means, like simultaneously. So when you have a concurrent validity, you're going to, like, someone comes up with a new assessment for whatever. They come up with a new assessment, but they want to see, is it valid? Remember, that's the whole point, is this valid? To see if it's valid, what they do is they concurrently, like simultaneously, give the new assessment to the people along with a gold standard, one that's already been proven to be valid. And what they're going to do is compare, right, like the new assessment's validity. See, does it correlate to the score on the gold standard? But it's concurrently, like you have a new one and like your gold standard. And then concurrently, like at the same time, you're going to give that assessment. And you're going to see, do the scores on the new assessment correlate to the gold standard?
Okay.
So, like I was saying, usually there could be, how these tests are, sometimes there are exceptions, but usually that's why I have it down here like this. Some of the keywords I've noticed will be like at the same time, or you'll have like a new test and an established test, and like given simultaneously. This is usually, those types of words right there is what I usually see with those types of questions, like if it's concurrent validity. So that's concurrent. Okay, the other one that I struggled with for a while too was construct. So I think the best way to think, or the way that helped me with this one, is first just to think about construct all by itself. Sometimes they'll just say construct validity. They won't go deeper than that in some questions. Those are the lucky questions. Okay, if it doesn't go deeper than that, it's way easier. All it means is in society, we have certain constructs, right? We can't measure it like we measure blood pressure or a fever or oxygen levels, right? We've constructed things like happiness. Well, how happy are you in life? Well, that's something we've constructed, and society has constructed that. So it's really hard to measure, right? Wouldn't that be funny if we went to the doctor and they could like put the blood pressure cuff on us and would like give us our happiness score, right? Like you can't see that. So that's why it's called a construct. If you get a question and that's all it asks for, like you're done. It's going to be something society's constructed. If you're unlucky and it gets a little deeper than that, it splits into two types, okay? There's the convergent, and then there's the divergent, okay? And I think the easiest way to think about this is if you have convergent validity, again, we have like two assessments. You have depression, something measuring for depression. Well, guess what? It should strongly correlate or relate, right? We're to relate again, with another assessment that's also measuring for depression. That's what you would want them to do. Converge. Converge is just like come together. You want them to be converging. If I give you and Sophia an assessment on happiness, right? How happy were y'all with this session, right? I want it to actually really be measuring for that. And I would compare it. Let's say I could find an assessment for happiness that already had been shown to really work. I would want it to converge with that. Now, what I would not want to happen is, let's say I wanted to measure y'all's happiness with this session, but let's imagine that instead it was measuring your IQ. Like, that's what I don't want. I don't want that to happen, right? I want it to literally discriminate. That's why sometimes I say it because it helps people remember in myself. This is the only time discrimination is good. You want the test to discriminate against other things you don't want to test for. That would be divergent. You want them to move apart. You want your assessment to only test for depression, right? You don't want it to correlate with IQ. Yes, I know. What do you think? Did that help any? Or did that muddy the waters?
No, I think it was helpful, but I think I'll have to watch the video again and again.
Absolutely. You know what, too, I can do? I would upload this PowerPoint, but I hate to because it's for like all the NCE people, and I would hate to give you more information than you need, or like information that's not relevant to you. That's why I've just been going by Dr. Pam's only, because what I've been using is what she specifically had for today. But you know what? I could take a screenshot. Let me see, of this. And put that. Let me see if I can upload this validity. I'll tell you something else too that really helped me, Sophia, before I took my test and passed it. Wait, let me see if I can put this in the stop sharing. Okay. Validity. All right, let me know if you see this, Sophia, in the chat. Yes, okay. And then I'll do the types of reliability on the next slide, since she said that's what y'all are tested on. Okay.
So validity is accuracy and
Yes.
right? That's okay.
Very good. Yes, and then remember I said one of the things that helped me is in validity. The second letter is an A, and so I just said to myself that A stands for accuracy.
Okay.
It doesn't really, obviously, right? But it's one of the ways I just help remind myself. Oh, there we are. Okay, I was like, I've lost y'all. Okay, let's see. Reliability is here. So yes, ma'am, reliability is that consistency. You do it and you every time, right? Like like, that's why Dr. Pam uses that about a date who's reliable. He calls you every day. He shows up every time he says he's going to show up. But it doesn't mean he's valid. It doesn't mean he's accurate who he says he is. Yes. Okay. Good questions. Yeah, those can be rough at first. Oh, but where I was going with that thought, Sophia, one of the things that helped me, I forgot, I was going to tell you something that helped me, and then I got busy trying to send that to you. If you go on ChatGPT and paste into it that slide, exactly like what's on that slide, and say, I need hard questions, just like, and then put in the name of your test. Like for me, it was the NCE. And then let it know, like, you need to be drilled on validity questions. That's one of the ways I really got down concurrent versus construct validity, where I could like recognize it in the questions.
Okay.
Yeah, you just have to be really bossy to it. Like, you have to really tell it what you want, right? Like, I want to be drilled on concurrent validity compared to construct validity for this, just like this exam. And then you want to put the name of your exam so it will word it the way that exam works. That's what that really helped me. All right. Let's see here, y'all. Wait, no, we gotta find those questions. No, are y'all ready for me to torture y'all with some questions? Okay. Maybe. I know, right? It's too much, really. It's too much, isn't it? Oh, what happened? Let's see here. Tech issues, of course. Excuse me. Let's try that again. See, even my laptop doesn't want to do these questions. It's like, I don't want to think this hard. Okay. These are not numbered. Okay, so Sophia, would you feel comfortable? Would you like to read the first one for us? And
Sure.
Okay.
A correlation coefficient that is not possible is.
And then, are y'all familiar with like the Dr. Pam approach to questions? Do y'all feel comfortable with how she does that yet? Or is that a little new?
With the eliminating the two answers and then going back to the question?
Yes, exactly, right? So you read through all your options and then you're going to eliminate two first. Absolutely.
Okay. I think for that, I don't quite understand this term.
You are totally fine. You mean the correlation coefficient? You are totally fine. So back in that handout that you'll have after this, thank goodness, right? Near the beginning of it, that's probably why, because I covered it like over an hour ago, probably. I was talking about that correlation coefficient, that is just about relationship. And it can only go from a -1 to a 0 to a 1. That's all it can be. It can't be above 1. It can't be below -1. So looking at our options here, right? 0, yes, that can be a possibility. Is -0.6 lower than -1? Yes, so that's a possibility. Can we get up to a +1? Yes, absolutely. But we can't go past 1 in either direction. So the one that's not possible would be.
So I guess you could eliminate 4 and then you eliminate 2.
We could definitely. So wait a second. A correlation coefficient that is not possible. You know what I hate? This is a not question. You know those except questions? What it is they literally work opposite. You know how normally we have 3 wrong answers? And 1 right answer? When you have a not question, you have 3 right answers and 1 wrong. We're literally looking for like, who's the 1 wrong answer here? It's like backwards. I hate them. I hate not questions. This is a not question. So we're looking at which of these is not possible. So we know a 0 is possible. That can be true. We know that negative 0.6, that can be true because we can go all the way to a negative 1. We know 1 can be positive. We can go all the way up to a positive 1. But we cannot go above positive 1 or below negative 1. So the one that's not possible would be only the 1.26. Wait, does that make sense, y'all? Wait, it's okay if it doesn't. You know what? Let me try. Let me try drawing this out. Hang in there with me. I have an idea. Because I promise, once you get it, it becomes
if the
easy.
scale only goes to 1, isn't it 1.26 past 1? So you can't go there.
Exactly. I'm going to draw it out, Sophia. Give me 1 second. Here's a white. All right, let me share my screen. Where is everything? Let me share my screen with you here. I'm going to draw something out for you that helped me share. Here. Okay. So on here, well, okay, can y'all see this whiteboard? Do you see a whiteboard? I can't hear you. Yeah, okay, sorry, thank you. I can't see your faces right now. So when we have a correlational coefficient, we can have a 0. We can go up to a +1 to the right, and we can go down to a -1 on the left. And we can do anything from a 0 to a -1 and anything from a 0 to a +1, but we can't go above +1 or below a -1 for a correlational coefficient. Right, so 0 means there's no relationship. No relationship here. +1 means we have a super strong relationship where it's either both going up or they're both going down. It just has to do with the direction. If we have a -1, that's also a super strong relationship. It's just the arrows are going in different directions, right? That's why I said, I'm going to say it again, right? I go to take my exam. The color of socks I wear on the day I go to take my exam, that's a 0. There's no relationship between the color of socks I wear and me making a good score on my exam. There's no relationship. If I have a +1 relationship, that's the strongest relationship I can have with the +1. All it means though, Sophia, is both arrows are either moving up or both are moving down. Okay, so for example, if I study and I come to Dr. Pam's group, see, I'm going up. I'm studying and studying and studying, right? Well, my score is probably also going to come up with that. I'm going to make a higher score. That's like the +1. Both the arrows are moving up. But don't be fooled. They could both go down. I stop studying. I'm going less and less studying. I don't show up for any study groups. I never study. My score will probably also go down. See how they're both going down? That's all it means by positive. It just means the arrows are moving together. Both things are either increasing or both things are either decreasing. Okay? If it's the -1 relationship, again, that's as strong as it can get. -1 or +1. What's weak is as it goes towards 0. As it goes towards 0, it's a weak relationship, okay? Excuse me. So with the -1, that's when the arrows are going in opposite directions. So I start hanging out all the time with my friends and family. I never study. It's going down, down, down. No, that's going in the same direction. What was the example I used a while ago? I had it all worked out. This is so funny. Oh, we'll make that go up. I'm starting to party a lot and hang out with friends. It's going up and up and up, but my grade is going down, down, down. There we go. Okay. So let me summarize that one more time, because this one's important and it's not hard. Once you get it, I promise you got it. Basically, you read your problem on your test. If it's at 0, no relationship. 0 is no relationship, okay? If it's getting closer to 0, like 0.1, -0.1, whether it's negative or positive, Sophia, as it gets closer to 0, it's getting weaker and weaker. The closer the number on your exam, if it gets close to +1 or -1, don't be fooled by the negative part. Closer to -1 or +1, the relationship's getting stronger and stronger. A -1 or a +1 would be the strongest relationship possible. right?
Okay.
Positive and negative just has to do with the direction, right? If it's positive, they're both up or both down. If it's negative, one's going up and one's going down.
Okay.
I know.
So basically, if the number is closer to zero, it's a weaker
Yes.
relationship. But
Yes.
if it's closer to the one, it's a stronger relationship, right?
Yes, positive one or negative one.
Or
Either
negative
one. Nice job. I think we got it, Sophia. Yes. So see if you can tell me. Good point. Let's do it like in your words. How? So yes, you've got that first point. The second point is, what does the positive one and the negative one then mean, right? Like, if it doesn't mean bad or good, right? What does it mean if you have the positive one compared to the negative one?
It just means it's a stronger relationship.
Well, getting closer to either the positive one or the negative one. But remember, if it's a positive one, it just means both arrows are moving up or both arrows are moving down. I think of them like parallel lines. They're moving together.
So negative is when it's going up and down?
Yes, good job. There it was. That's it. Nice.
Okay.
It just means it's moving in opposite directions. Okay. Nice work. Good. You know what I did? When I got to my exam, that's literally one of the things I drew down on my little piece of paper. As soon as I got in there, I put correlational coefficient, -1, 0, +1, to just remind myself of like how it worked. Yeah. Okay. Oh, back to this horrible question, right? Okay. So coming back to the question. Wait, I gotta share the screen. Is this making more sense now, Sophia? Like, where I'm getting that answer from tab issues. Okay. Does it make more sense where I'm getting that answer from? That what is not possible is the 1.26.
It's number 4. Yeah.
Perfect. Okay, nice job. All right, now I'm gonna pick on Jennifer. I'm gonna torture Jennifer now. Jennifer, can I torture you for a second? I thought that would be cool. So you're gonna try this second question.
The probability factor is not represented by a simplified samples, ratified sample, photo sample, and the probability possibility. I'm gonna say answer system. But because it's a photo, to me, photo means ability to
Right. Yeah, you know what, Jennifer? I'm not sure what's going on with the audio. The audio is kind of, but it could be on my end. Sophia, were you able to hear Jennifer, or was it kind of muffled?
It was muffled.
Okay, I'm so sorry, Jennifer. I'm not quite sure exactly what you said, but you want to put your answer in the chat?
Mm-hmm.
3. A probability sample is not represented by a well, I can see definitely where you got that from because of it saying quota, right? But this one, guys, the answer for this one would actually be 1, simplified sample. But hang in there. Let's check out why, right? Let me go back to let's do a quick search and I'll show you why, right? We always want to know why. Let me share. Remember back that way too, when you get done, you can see in Dr. Pim's document here. Can y'all wait, are y'all seeing her document? Okay, I'm just making sure it changed. So back up in here, we do a search up in sampling. Here we go. In sampling methods. Right here, Jennifer, do you see how when we sample, it's divided into probability sampling? That's kind of weird, right? Simple, random, the simplified sample is not among the probability samples. The simplified sample is not. Does that seem odd to y'all? Or is this just me that this seems odd too? Do y'all see why I feel like this is an odd question? Like, okay, like back in the handout, right, it says, okay, probability sampling, and it says simple random is probability sampling. But in this question, it says the simplified sample is not among the possible probability samples. I feel like it's almost saying the opposite thing. Do y'all feel like it is? Or is that just me? Do y'all? Yeah, right? Like, okay, right? Like, I'm looking right here, it says sampling methods, and it says, right, like types of probability sampling, right? It says these three: simple, random, stratified random, and cluster are all probability sampling, right? Now, coming back to the question.
Just a question.
Mm-hmm.
So for sampling, would you say there are three different ways to do random?
Right, exactly. These are all three of these bullet points. These are types of probability sampling. Okay. Right, simple random, stratified random, and cluster.
Okay.
Yes, ma'am. And then great clarification, because underneath that, this is non-probability sampling, and that would be quota and accidental. That's why I feel like this question's a little weird. Let's go back and read it again. Mm-hmm. A probability sample is not represented.
That would mean one is not probability.
So maybe you know what? And this is a not question. So we should have three that are a probability sample. Which of these three would be a probability sample?
Simple,
exactly. Simple, random.
Yeah. We're here to quota probabilities.
Exactly. I agree with you. I'm not sure why. I'm sorry. I'm looking here at the answer. Right here, I printed off the answers, and it says that the answer is 1. But a probability sample. I want to go back up again. This is. I feel like this is gaslighting me. Let's see. Probability sampling, simple random. That's simple random. Stratified random. Random. Okay. And yet it's saying simplified sample. Oh, is that what it? Oh. Is it? Do you see how this says simple random right here, guys?
Yeah.
Simple random, but this says simplified sample.
Oh.
So, okay. Oh my word. That was severe. I was like, you know, when you feel like you're gaslit by like the answers, and you're like, this is not true. Like, I know yours is lying. What is wrong? Yeah. Okay, just read the question, Sarah. Okay, so read. There you go. Simplified sample is not the same as, let's go back to here, as simple random. It sounds really close though, doesn't it?
But is quota a probability sample too?
I'm sorry, do what now?
It says quota is...
See, that's one of the reasons I got confused, and I'm still confused, is exactly... right here, right? It says non-probability and then quota. So I thought that would have been the answer. Is that what you were thinking, Jennifer?
But even if it's not the answer, there's two wrong answers there, because it's saying simplified, which is not a probability sampling, and it has quota there, which is also not a probability.
Exactly. That's why that's one of the reasons I was confused, because I'm like, quota. Yeah, quota is definitely on there. Quota is not a probability. So I feel like both of these are not a probability sample. Like, based off of this, right? You know what I mean, guys? Like, if we're reading this, right? And it says right here, non-probability sampling. And it clearly, I mean, quota is the very first one it has down. Right? That is very strange. You know what? Let's put it in on ChatGPT. For real. Let's see what it says, okay? Because that is very weird. Do you see why that's confusing, Sophia? Quota is like literally the first one in non-probability, but it's not flagging it in this question as a probability, as not a probability. But you know what? This isn't letting me copy and paste, so I'm gonna have to type it out. Give me a sec. Let's figure this out right now. That really bothers me. All right, can you see my screen?
Yes.
Perfect. Okay, let's see what it says. A probability. I don't know why, but this document doesn't let me copy and paste. A probability sample is not represented by a simplified sample B, stratified random sample C, A, B, C. Quota sample, and then D. Random sample. Okay, let's see if we can figure this out, because quota, I feel like should be, yes, look at this. It's saying quota sample. See, this simple random is saying it probably meant. Remember how the A was worded funny, like simplified sample? And it's saying it probably meant simple random. What do y'all make of this? Right, it's saying quota.
Would be a mistake, right?
Yeah, I think we found a mistake in the book. For real, right? Because, all right. I think we literally found a mistake in the book, because it is saying, like you were saying, Jennifer, I was like, this makes no sense. Quota's doesn't match on here. Well, there you go, guys. All right. Did that help, seeing that explained?
Yeah.
Yeah. And we knew it, right? That's why we were confused. We knew it from here, because we're like, wait, quota's right there with non-probability. Like, it's literally the first example it gives. Oh my life. Okay. Well, we'll see if the next one's right? Okay. Oh, this is a long question. Do you want to try this one, Sophia?
Yes.
Okay.
Social work program evaluation research methods.
Okay, this is like an ethics, I think, type question. But there are two that I think, right, we could definitely cross off first. What do you think?
If I had to eliminate two, I would eliminate 4.
Nice job. Yep.
And I would eliminate one.
Absolutely. Yeah, I hope so, right? Like, that is definitely not true. Number one is definitely not true.
Now I'm going to go back to the question.
Yes.
I would say 3.
I can see where that's coming from. Well, wait, go. But all right, I'm gonna go back to the question 1 second, Sophia. So, do you see where it says on the last sentence, select the statement below that expresses a major ethical dilemma and social work research? Major ethical. So, it is true that it would be unethical to perform research on them. Oh, that's why it's not informed consent right there. Okay, that answered it. Do you see the second sentence in number 3? It would be unethical to perform research without their agreeing on its importance. No, it would be unethical to do it without their informed consent, but they don't have to agree with you how important it is. Right? I bet that's probably your mind. That's what my mind at first, it translated it as like, oh, informed consent. No, it's talking about importance. So yeah, you could research on me, and as long as I give you my informed consent and all the ethical stuff, right, I don't have to agree with you that it's important research. To me, I might think this is not that important, right? So that's why we would cross out 3. Like clients, it is possible for sure that clients may not understand the value and they may not be cooperating, right? That's for sure. But the one that truly like makes it where that could not be the answer is the second sentence. It is not unethical to perform research without people agreeing with you on its importance, right? Like that's not unethical.
Oh, right, that's different.
Right, exactly. So knowing that, which one do you think you would which one do you think you would pick?
Number 2.
Absolutely. Nice work. Yeah. That's a lot of words, right? I'm telling you. Ooh. Jennifer, do you like doing some math today? Okay. This is a math question.
I'll try my best.
I know, right?
The research report that the finding is significant at the 0.01 level. They are stating there is no significance. There is 1 chance in 10 that the result occurred by chance. There is 1 chance in 100 that the result occurred by chance. The sample is too small.
Right, so always looking, y'all, for the 2 we can take out first, right? And I tell my clients all the time, I'm like, start with what's easiest, right? Cross out.
So, I mean, looking at the question, if you're saying that it's significant, which one is significant? Maybe take out 1.
Absolutely, nice job. We're going to take out 1. Perfect.
And maybe 4.
Nice work. Yes, those are the 2 I definitely would start out with too. I would eliminate 1 and 4. Absolutely. So now we're down to 2 and 3. This is the one with a little bit of math. So remember that trick from when we were little kids and you move the decimal point? And if it's like 100% or like by 100, you move it 2 times, right? So if we have 0.01, how many times would I need to move my decimal point to the right to go from 0.01, like to get past 1?
So the answer is 2?
Well,
the answer is 2?
It's going to be 3. Hang in there with me. I know you're like, well, it's so mean. Wait, no. The reason why is however many times you move your decimal point, that's how many zeros you'll have. So if we had moved it 1 time, we would have 1 0, and that would have been 2. If we have to move the decimal point 2 times, go by the zeros. However many times you move the decimal point, that's going to be your zeros. So there's literally going to be a 1 chance and 100. But, right, so if you get a question like that, move those decimal points and then that, make it equal to the zeros.
Okay.
So we moved it twice, so 2 zeros.
Thank you.
Absolutely. Well, Mastermind, would you like to maybe take the next question? It'll give Sophia and Jennifer a break. I've been torturing them.
I'm hoarse.
Oh, no problem.
I got a call because I heard a crash. Somebody just hit my car, and the person died. So I'm hoarse. I can't.
Oh my goodness.
What?
Yeah.
I am so sorry.
That's why I jumped off. I heard it crash, and they flipped over. I had to go downstairs to talk to the police. They hit my car.
Oh my goodness.
Oh my
I am
goodness.
so sorry. What in the world? And the person died?
Yeah. She was drunk.
Oh my goodness. I'm so sorry. Well, I am so, that is so upsetting. Well, listen, yeah, definitely don't worry about it at all. Okay. Thank you for letting me know.
Thank you.
Yes. Sophia, feel free to let me know, okay? Do you want me to like read this one out, or do you feel good taking this question?
I can take it.
Okay, thank you. Let's see where the next one. Oh, of course, Sophia, you're the lucky person. Guess what you got? You got exactly what you asked me about, literally. Mastermind, is there anything we can do? I feel badly just moving on to the next thing. Is there anything we can do?
No, it's okay.
Okay.
Thank you.
Yes, for sure.
Stability refer to the relationship between I'm kind of stuck with this question.
I'm sorry, do what now?
So I'm stuck.
Oh, that's okay. But I'm so glad you got it. This is like the perfect question because I think it's going to help show you like what you were asking me about earlier, how it will look in a question, right? So is it okay if I read it? Is that
Absolutely.
okay? So we have construct validity refers to the relationship between, all right, is that 1, independent and dependent variables, 2, a population parameter and a test of significance, 3, variations in scores and inconsistencies in measurement, or 4, is it about, a relationship between an abstract concept, and an empirical measure. Okay, so working Dr. Pim's method, right? I know that construct validity, remember a while ago I was telling you, has to do with society's constructed something. It's something that's hard to measure, right? So remember I said it's not like taking your blood pressure or your temperature. Like there are no numbers. So something I can take off right immediately is number 2, right? That would have a test of significance and parameter. Hear all that number type stuff? It's got nothing to do with numbers. I know that would also get rid of 3, right? That's measurement and scores. I don't have any measurement or scores for construct validity, right? Remember, it's something that's hard to measure, like happiness or sadness or anxiety, right? So I can get rid of 2 and 3. That's at least what I would get rid of first. That leaves me with 1 and 4. Well, I'm back to actually the same thinking. Independent and dependent variables, again, have to do with more like measurement type stuff. This has nothing to do with an independent or dependent variable. That just leaves 4. Like, I can eliminate 1, 2, and 3. That all has to do with like measurement. Now, what will help, I think, Sophia is in number 4. Look at this very first part, an abstract concept. That's literally like, that's the clue right there. An abstract concept. Something abstract is like, it's like abstract art, right? It's like hard to tell what it is. You know, have you ever seen like that artwork and you're like, what is that, right? You're like, I have no idea what this is. That's like this right here. Happiness and sadness and a lot of the stuff we work with like in therapy is actually abstract. So construct is going to sound like that. Like it's hard to measure. It's like abstract. Well, what does happiness look like? How do you measure it, right? You can't really measure it. It's an abstract concept. So that's like really the clue I'm going by. I know that with construct validity, it's something abstract in society that we've constructed. That's why it's called a construct. We've constructed what happiness looks like, or sadness, or whatever. And it's hard to measure. So that gets rid of 1, 2, and 3. You can't measure an abstract concept. Okay? All right. Y'all, you're doing great, okay? Like, hang in there. These questions are hard. These are hard. Do you feel, Sophia, though, and like you can be totally honest, do you feel like seeing it in a question helped a little bit with what that might will look like in a question?
Yeah, I think so.
Yeah? Okay, look for stuff that's hard to measure. That's going to be construct validity. Here, it's hard to measure. You can't really measure it. Not with numbers and stuff. Okay, let's see. Let's try one more. All right. All right. Oh, we're back to... we're back. All right, y'all, I know you can do this, okay? Like, think about... Remember this right here, the -1, the 0, and the 1 conversation? This is that conversation. We're back to that conversation, okay? Jennifer, you want to try your hand at this one, maybe?
Mm-hmm. The closer the R value is to 1, the weaker the association, the stronger the association, the more inverse the association has nothing at all to do with association. I'm gonna limit.
Oops.
I'm gonna limit 3.
3, absolutely, yep.
I'm gonna eliminate 1.
Did you say, and you said 1, right? Nice job. Yep, 3 and 1. You're right on track. And then I'm sorry, did you get rid of 4? Like it's still a little muffled.
Yeah, 4.
Nice job, Jennifer. So that would leave us with what as the answer?
I'm gonna say the closer you get to the 1, the stronger the association.
Absolutely, 100%. Nice work. Yes, Sophia and Mastermind. All we're dealing with here is, and it's in the handout, Dr. Pam, like prepared, right? That's in the chat. But the closer it gets to 1 or to -1, all that's showing you is a stronger and stronger relationship. A +1 or a -1. Okay, this question could have said, by the way, it could have said the closer the R value gets to -1, that would also be true. The stronger the relationship. Okay, so it doesn't matter whether it's the 1, like the +1, or the -1. The closer it is to 1, the stronger the relationship. The closer it starts getting to 0, the weaker the relationship. And 0 would be no relationship at all. Zero relationship, okay? Okay, nice work, Jennifer. All right, we're going to try, I think we're going to, this is our grand finale right here. We talked about this one too, right here. Sophia, you want to try the source of illness?
Source of illness among smokers can only be inconclusive and proven.
Oh, they're being a little tricky in this question. I'm going to give you a small hint here, okay? Remember earlier when we were working through Dr. Pam's handout, and it was saying, remember, correlation is not causation, that to be able to show a cause in research, you have to do experiments.
So it would not be experimental?
Oh, wait, is that Sophia?
Yes.
That's actually what it would be.
Okay.
Right? So that's why I said they're being kind of tricky here, because the two I know we could take off would be 1 and 4, right?
Okay.
Like, right. First, Dr. Pam says always take out 2 first. So I would take out 1. I know it's not a descriptive study. That one's obvious. I know it can't be epidemiology, like it's nothing to do with that. So that's left out.
But I would eliminate 4 as well.
Yes. But why I said they're being tricky is you see a longitudinal study that, I don't know, I feel like I've heard several times longitudinal studies done with smoking. And that's why I was like, wow, they're actually being kind of tricky here, because that still would improve it. And this is really good to remember. No matter all of this research right here, it doesn't do what's caused conclusively and unequivocally prove. To conclusively and unequivocally prove something, you have to do what's called the experiment, an experimental study. Experimental study. Guys, all right, you made it through research. Maybe, I'm hoping you don't have as many research questions. So, for example, why I'm saying that, like on the NCE, that's the smallest content we have, like where questions can come from it. So technically, this sounds terrible, but technically, if somebody really knows everything else for the NCE, they could flunk that section and still pass. Is it like that for y'all, or is this something y'all have to really know? You don't know?
Depending on the time.
It's not that important?
No, so it is. Some exams, like one exam of mine, I had like 8 research questions.
Uh-huh. Oh, wow, okay.
So it depends on what you get.
I see. Oh, okay. Tears, right? Okay. That's tears. Well, I love getting to meet y'all, and thank you for engaging and like hopping in, even though I'm not Dr. Pam. I appreciate it. It made it easier for y'all to hop in and like answer questions and stuff. And I hope y'all have like a great holiday season, and maybe will y'all get to kind of relax some this week, or do y'all have to like just keep a usual schedule going or work going? How is that?
My schedule is relaxed for the holidays, so clients don't really want to meet.
Right? So you get a little bit, maybe extra time to relax. And how about you, Sophia?
I'm actually having a regular schedule because I'm going to go on vacation in a couple of weeks.
Oh, good for you. Okay. Well, we're all back here in the cold weather, right? Okay. Good for you. Okay. And then Mastermind, thank you for coming back after that and letting us know what happened. I love this dog. May I ask, what kind of dog is, I love dogs. What kind of dog is this?
He's a Shih Tzu.
Oh, it's so cute. I love it. All right. Well, y'all, it's been a pleasure, okay? Go relax after this and shake off all this math, right? And good luck with your exams.
Thank you.
Thank you. Bye for now.